Hey everyone, it's Mr. Mechnick. Today we're going to talk a little bit about polarity and why this is such an important physical property of matter that relates to many different molecules that we've been learning about in class. So first off, polarity really relates a lot to solubility. It relates to individual molecules, their melting point and their boiling points and freezing points. So it also determines how these molecules might interact with other molecules. Are they going to be attracted towards one another? Are they going to be repelling each other? So a lot of this has to do with where these electrons are found around individual molecules. And when we see this unequal distribution of electrons, we can say that a molecule is polar. So one of the things that we're going to focus on today is how we can actually go ahead and determine if a molecule is polar or not, simply based upon what's called its electronegativity. So when we think about water, and as we've been learning about water, we kind of said, well, water is a polar molecule because it has slightly more electrons in this electron cloud region. So where there's all of these electrons gathered around the nucleus of the oxygen atom, plus the shared pair of electrons, there tends to be more oxygen or more electrons near the oxygen, so it has a greater negative area. And on the other side, we know that there's less electrons where those hydrogens are, so it has a slight positive charge. So over here you can see these what's called a dipole. So this is a negative dipole and this is the positive dipole for this water molecule. And so because of the electron distribution, we can basically say that water is considered a polar molecule because it has this uneven distribution of electrons. So when you have this high electron density around a certain region of a molecule, it creates a substance to be polar. So to determine polarity of a molecule, we can use what's called the electronegativity of an atom to determine where those electrons are possibly found in that molecule. So electronegativity is a characteristic of atoms where it's their measurement of the ability of an atom to attract electrons in a chemical bond. And what we can see on the periodic table is that the atoms that are found over here on the left side, they tend to have very low electronegativities because they typically have fewer electrons in their outermost shell, and they're going to tend to give those up. And these atoms over here are going to be the atoms that want to attract electrons, so they are said to be more electronegative. So the highest electronegative atom on the periodic table is fluorine. It has a value of 4.0. If you look on the opposite corner way down here on the bottom, francium has a very low electronegativity because it has this one valence electron and it's easily going to get rid of that. So it's not going to want to attract electrons. It would rather give up electrons. So scientists have determined that if there's an electronegativity difference between two atoms that are bonded together and it's greater than 1.7, then we can refer to that bond that holds those atoms together as an ionic bond, which makes it an ionic compound. If the difference between the electronegativity of two different atoms is between 0.5 and 1.6, then we have a polar covalent compound. That means we have these unequal distribution of electrons and we have a polar substance, just like water. If we have a substance that has a very low electronegativity difference, so if you have two oxygen atoms bonded together, the electronegativity difference would be 0, which tells us that we have a nonpolar covalent substance. So just to give you an idea of these numbers, here's the periodic table that you'll always have reference to. You don't have to memorize these numbers, but you can use this to help you determine what type of compound a substance is. So for instance, here are 3 practice problems. We're going to assume that all 3 of these elements, cesium, iron, and sulfur, are bonded to iodine. So the first thing we would need to do is we would need to look up the electronegativity difference for iodine. So if we go back to this periodic table, we can see the electronegativity difference for iodine is 2.5. So to figure out what type of compound iodine and cesium would make, we just have to use the electronegativity value for iodine, which is 2.5, and then we look it up for cesium, and when we look up cesium, we would find the electronegativity difference, or the electronegativity would be 0.8. So we do this heavy-duty math, and we get a value of 1.7. So now if we look on our chart from the previous slide, we would see that if it falls in that 1.7 category, it is then an ionic compound. So let's try the next one. So again, electronegativity of iodine is 2.5. We subtract it from the electronegativity of iron. So if we look up iron on the previous page, we would find out iron has an electronegativity of 1.8. So we subtract 2.5 from 1.8 and we get 0.7. So looking back on our chart, we find that 0.7 would lead us to have a polar covalent compound. So this tells us that we're dealing with something that has an unequal distribution of electrons. There's a higher density of electrons in one part of the molecule than the other part. And we can do the same for sulfur, which is 2.5 for iodine minus 2.5 for sulfur, which gives us an electronegativity difference of 0. So if we have sulfur and iodine bonded together, this would be considered a non-polar covalent compound. So this is just an easy way to help you determine if something is considered polar or not polar. So you will always have access to the chart with the electronegativities, and you'll be able to reference that to help you determine the answers to problems like this. So here are some practice ones. Go ahead and try these. Bring your answers back to class tomorrow, and we'll go through them first thing. Thanks for watching.